In our own solar system, and in every solar system discovered so far, the first large objects to form are asteroids. Long before the birth of planets, these rocky fragments were already spinning around their young stars. There were no stable orbits yet, no well-formed worlds, only chaos. Trillions of rocks and stones churned within the swirling disks of dust, orbiting in what can only be described as cosmic turbulence. Imagine a vast merry-go-round of space debris encircling the sun, where collisions were inevitable and frequent. Some of these rocks clumped together, gaining mass with each impact, slowly growing into the planetesimals that would one day become planets. Others were cast out or destroyed in the relentless gravitational ballet. Yet millions survived, locked in orbit as asteroids, each carrying a unique signature from the early solar system. The asteroid belt, situated between Mars and Jupiter, is the most famous graveyard of these ancient wanderers. But calling it a belt may be misleading. It's not a dense wall of rocks as often portrayed in science fiction. Instead, it's a sprawling region filled with scattered remnants, millions of space rocks, most separated by hundreds of thousands of kilometers. Still, gravitational disturbances from Jupiter's immense mass have prevented these rocks from coalescing into a planet. Each asteroid within the belt is a window into a different chapter of our solar history. Some are made primarily of metal, others of rock, and some contain surprising amounts of water ice. Their diversity speaks to the incredible range of conditions present during the formation of the solar system. Studying them helps scientists reconstruct those ancient environments. What's fascinating is that the paths of asteroids aren't fixed. They're influenced by gravitational tugs from planets, especially Jupiter, and by subtle forces like the Yarkovsky effect, where the way an asteroid absorbs and re-emits sunlight can slowly alter its trajectory over millions of years. This means asteroids can migrate from their original orbits, making their way closer to Earth or out into the deeper solar system. They don't all follow the same direction either. Many move in eccentric, tilted and unpredictable paths, often crossing the orbits of planets. Sometimes they collide with each other in spectacular fashion, sending fragments flying in all directions. These collisions can create asteroid families, groups of fragments that share a common origin, still traveling in similar orbits thousands or even millions of years later. While some asteroids remain in the main belt, others have been captured by the gravity of larger planets. Jupiter, in particular, has collected its own group of asteroids called the Trojan asteroids. These objects travel in stable points ahead of and behind the gas giant along its orbit, another cosmic reminder of how gravity sculpts the architecture of space. One especially intriguing class is the near-Earth asteroids. These are the ones that come close to our planet's orbit. Some are harmless, simply passing by at safe distances. Others, however, raise alarms. Even a small asteroid, if it were to impact Earth, could unleash devastation comparable to a nuclear explosion. That's why international observatories and space agencies work tirelessly to catalogue and track these celestial neighbours. Yet, despite the danger they pose, asteroids offer incredible opportunities. For instance, they contain vast resources: iron, nickel, water, and even precious metals like platinum. In the not-so-distant future, asteroid mining could become a reality, unlocking new possibilities for space travel and industry. Water extracted from asteroids could support deep space missions by providing both drinking water and fuel via electrolysis. But returning to their story in the early solar system, it's important to understand the sheer speed at which these objects move. Traveling at tens of thousands of kilometers per hour, their collisions are not gentle bumps. They are violent impacts that melt rock, release massive energy, and reshape surfaces. Over time, these impacts grind asteroids down, leaving many as rubble piles held together loosely by gravity. Some, however, have survived relatively intact, preserving their original structures for billions of years. These pristine relics are like time capsules, and they're prime targets for robotic exploration missions. NASA's Dawn mission visited Vesta and Ceres, two of the largest bodies in the asteroid belt, revealing fascinating geology and possible signs of past water activity. Ceres in particular may even have an internal ocean. Another factor that makes asteroids so interesting is their unpredictability. While their general orbits can be mapped, small forces like solar radiation pressure or gravitational nudges from other objects can alter their paths over time. This makes long-term predictions of their movements a complex and ongoing challenge for astronomers. Beyond the scientific curiosity, asteroids serve as cautionary tales. Earth has been struck before, and it will be again. The Tunguska event in 1908 flattened over 2,000 square kilometers of Siberian forest, likely caused by an asteroid just 50 to 60 meters wide. More recently, in 2013, a 20-meter asteroid exploded in the atmosphere over Chelyabinsk, Russia, injuring over 1,000 people. Yet these events have also spurred innovation. NASA's DART mission, Double Asteroid Redirection Test, successfully altered the orbit of an asteroid in 2022, proving that we can take action against potential threats. It was a small but vital step toward planetary defense, turning science fiction into science fact. Asteroids are not just rocks drifting in space. They are players in a cosmic narrative of creation, destruction, and rebirth. From shaping the planets to potentially ending life, from preserving ancient chemistry to promising future resources, they are among the most dynamic and meaningful objects in the solar system. At Infinity Beyond, our mission is to bring you closer to these forgotten giants of the cosmos, to uncover their secrets, understand their dangers, and celebrate their contributions to the story of everything. Stay tuned as we journey deeper into the asteroid belt, where every rock has a tale and every orbit carries echoes of the past.